Okay, we begin our chapter review here, dealing with all the conic sections. For this first problem, we see that there is a minus between the x squared and y squared term, and that tells us we're dealing with a hyperbola. Since x squared is listed first, I know that this is going to open to the left and to the right. I first need to find my center, which will be at positive 2, negative 1. So let's write that down first. Positive 2, negative 1. Okay, let's go straight to the graph and plot that at 2, negative 1. Whoops, that's in the second quadrant. We look at the denominators. Beneath the x squared term, we have a 16, which square roots to a 4. And beneath the y squared term, we have a 4, which square roots to a 2. That tells us to draw this hyperbola, we need to first begin with a box. We're going to go up and down 2 units, and left and right 4 units. And through those points, we're now going to draw a box. And that box will help us with how wide open and what the curvature should look like for this hyperbola. We're now going to draw in the diagonals of the box, which turn into our asymptotes. And since this begins with x squared, this is going to be opening to the left and to the right, as I have drawn in right there. Now, let's identify a couple of key features. The vertices are going to be 4 units to the left and the right of center, which is going to mean adding and subtracting 4 to 2. So the foci subtracting 4 will be at negative 2, negative 1, and then 4 to the right at 6, negative 1. The equation of the asymptotes will be y plus 1, that's my y minus k, which we find up here in the numerator of the original problem, equals slope, which I'll hold off on a second, but I will put my plus and minus symbol down, times x minus 2, which is my x minus h. X minus 2, let me write that instead of the h. Now, what is the slope of those asymptotes? I see that I'm rising 2 and running 4. 2 over 4 reduces to 1/2, and there's a compact way of writing our two asymptotes. As far as the foci are concerned, we need to look at c squared being the sum of a squared and b squared. And we do know already what a squared and b squared are. In the original problem, that's our two denominators. So we are going to add 16 and 4 and get c squared equals 20, which tells us when we square root both sides that c will be plus or minus 2 root 5. Okay, now let's go through and find the foci themselves. They will be left and right of the center, and since the center was at 2, negative 1, we will affect that 2 there and have the foci at 2 plus and minus 2 root 5, negative 1. This next problem we can tell is an ellipse because there's a plus between the x squared and y squared terms with different denominators. The first thing we want to identify is the center of this ellipse, which will be at negative 1, negative 2. We get that by changing the signs that are coming out of these parentheses. Let's go straight to our graph. Negative 1, negative 2 is down in the third quadrant. We're going to look at our equation and analyze the denominators. The 4 square roots to a 2, the 25 square roots to a 5. Since the 2 is beneath the x terms, that tells us this 2 tells us to move left and right 2 units. The 5 is in the y squared term, which tells us it's a vertical movement up 5 and down 5 to get to the endpoints of the major axis. Now it's time to draw in the actual curve here as best as we can. The endpoints of the major axis, also known as the vertices, are 5 units above and below the center, which means we're going to be adding and subtracting 5 to this negative 2. They will be located at negative 1 comma 3 when you add the 5, and negative 1 comma negative 7 when you subtract the 5. To find the foci themselves, we need to calculate c squared equals a squared minus b squared, which will be 25 minus 4 for this problem. Since there is an addition sign between the two fractions in the original problem, we want to do a subtraction problem of the two denominators here. Remember that a squared is the larger denominator. C squared here is going to equal 21, and c will be plus or minus the square root of 21. And since the foci are always on the major axis, we are going to be going up and down root 21 to get to our foci. And these foci will now be located at negative 1 comma negative 2 plus or minus the square root of 21.